Okay, let's get started with Math 6, Module 6, Lesson 9, the mean absolute deviation, or MAD. Students calculate the mean absolute deviation for a given data set. So you're going to have a data set here, and I'll show you why. Students interpret the MAD of a data set as the mean, or as the average distance of the data values from the mean. And just like finding the mean, you have to have a data set. Okay. Example 1 says, talking about variability. Remember, we talked about variability and how if we had a line plot, we had all these and it was varied greatly as opposed to just everything being right here. I mean, it was still varied, even though there's only 2 data points, but this is much less variability than this. So that's what we're still talking about here, how much it varies the spread of the data set. So in lesson 8, Robert wanted to decide whether he would rather move to New York City or San Francisco. He planned to make his decision by comparing the average monthly temperatures for the 2 cities. Since the mean of the average monthly temperatures for New York City and the mean for San Francisco turned out to be about the same, he decided instead to compare the cities based on the variability in their monthly average temperatures. He looked at the 2 distributions and decided that the New York City temperatures were more spread out from their mean than were the San Francisco temperatures from their mean. Okay, so let's look at it here. What is variability? Well, variability is when not all the values in the data set are the same. When the values in the data set are all similar, there isn't much variability, but if the values differ a lot, there is more variability. That's what we were just talking about. What is a distribution that has no variability? What does it look like? Well, they're all the same, right? So that would look like if we had 8, they're all 8. There is no variability there. They're all the same. Okay. So what does distribution that has a lot of variability look like? Well, that means it's going to be spread out, right? It's going to be, they're going to have tons of different values. Okay. This says the following temperature distributions for 7 cities all have mean monthly temperatures of approximately 63 degrees Fahrenheit. They do not have the same variability. Okay, so there's A, B, C, D, E, F, and G. Now, 1 says, which distribution has the smallest variability? So we want to look at something that's really close together. All right, look at A. They are all right there together. Okay, so CD A has the smallest variability because all the data points are on the same value. 2 says which distribution or distributions seem to have the most variability. So we want to look for the widest spread variability, and it looks like CDD has a great variability there. Let's see what they said. 1 or more of the following are acceptable: D, E, and F. Okay, see how these are spread out a great deal too? Those are really wide. They appear to have data points that are the most spread out. Even though there are only 2 values, they're still spread out. Order the 7 distributions from least variability to the most variability. Explain why you listed the distributions in the order that you chose. Okay, so I'm just going to put like 1, 2, 3, 4, 5, 6, 7. I think there's 7. Okay, least, of course, is number 1 here. And this looks like 10. Maybe 2. It's hard to do without a calculator. I'm just going to guess right now. 4, and let's call it 5, 6, and 7. So we would go A, C, B, G, E, F, and D. Let's just see. Several orderings are reasonable. Okay. So they're just going to say your explanation of what's going to be the difference here. So if I was to explain this, I would say 72 minus 54. Okay. Because that is what looks to be the greatest value minus the smallest value, and that's 18. And then here it would be probably about 50. Well, we need to say 74 minus, what is that, about 57? And that's about 17. Okay, 17. So that's the reason why I picked that for 2. And then here we have 52. So 70 minus 50, we'll call it 53. That's another 17 here. That's the reason why these are really close. So I'm just taking the greatest value, subtracting the smallest value, and so that tells me the range, which is the variability. Okay. Now, do you think the distance from the mean is a good basis for a formula to measure variability? So what that means is, as we have taken and added up the values and found the average or the mean, we know this one's going to be the mean right here, right below all those values. This one's probably going to be something like this. This would be something here. This would probably be something over here. Something like this. So we're looking at the distance from the mean to each value. So from here to here, here to here. Would that be a good measure for variability? Well, yes. If there is not much variability in the data set, the values will all be close together. So the distance from the mean will be small. If there's a lot of variability in a data set, the data values will be spread out and some points will be far away. So let's take a look at A. If this is the mean, 64 is the mean, what's the distance away from the mean? 0. They're all on the mean, every single one of them. And if we come down here and say that, let's say that the same thing, let's say it's 64. Well, now we have 87 minus 64, take this value here, and that's going to give us 23. Well, that's a pretty wide distance there between the mean and the value point. So that is a distance that would tell us that there is a great deal of variability. Okay. Exercise 4 and 5 says the dot plot for monthly temperatures in CDG is shown below. Use the dot plot and the mean monthly temperature of 63 degrees Fahrenheit to answer the following questions. Okay, so 63 is our average. Fill in the following table for G's temperature deviation. Well, we would say 63 minus 53 is 10. So we would just do this for all of them. We would just subtract all these values from 63. Maybe I can write that differently and just say 63 minus all these values right here. And that's going to tell us the distance from the mean. And over here, it's telling us which direction. So if it's to the left or to the right, because we could have some that are both 5, but we really don't know which way it is. Is it to the right or to the left? So that's the reason why they do that. And if we do all of that, 63 minus 57 is 6, and that's to the left. And if you do all of those, you should get those answers. 70 minus 63, or if you continue to do 63 minus 7D, that gives you a negative 7. Well, that negative there tells you that it's going to be to the right. Okay, it's going to be to the right because it's 70 is a greater number, so that gives you a negative number. So what is, excuse me, what is the sum of the distance to the left of the mean? What is the sum of the distance to the left? So we'd have to add up all these lefts here. So 6 plus 3 plus 3 is a total of 12. That is the distance to the left. Now let's look at the sum to the right. Well, there's I'm going to start from the bottom here and go up. There's 12, 17, 18, 19, 20, 21, 22, I believe. Now let's see what they said. 22, the sum of the distance to the left of the mean is 22. Oh, I missed one. I missed this blue one up here. Sorry about that. Or this black one right here. So yeah, I need to go with all of these right here, and that is 22. Well, the sum distance to the right is also 22. And that should make sense, right? Because we're talking about the mean. So there should be about the same distance away from each other in those, the variabilities. Example 3 says, finding the mean absolute deviation. Sabrina notices that when there is not much variability on a data set, the distance from the mean are small, and that when there is a lot of variability in a data set, the data values are spread out and at least some of the distances from the mean are large. She wonders how she can use the distances from the mean to help her develop a formula to measure variability. So, using the data on monthly temperatures for CDG given in exercise 4 to answer the following questions. Well, here was our distances right here. We've already calculated those, right? Now, we already have the distance over here. It tells us from left to right. Okay? We're all good. We've already done all of this. So let's look at the next page and see if we can answer these questions. B says the absolute deviation for a data value is its distance from the mean of the data set. For example, if the first temperature value of CDG 53 degrees, the absolute deviation is 10 because 63 minus 53 is equal to 10. So that's the absolute deviation. Now, what is the sum of the absolute deviations? So we already did 22 to the left plus 22 to the right. Well, the sum of that is 44. And that's what they got right here. They just added them all up again, although we had already done that. So now this is the absolute deviation. This is not, well, this is the sum of the absolute deviations. Okay. This is not mad yet. This is just the sum of the absolute deviations. So now then C says, Sabrina suggests that the mean of the absolute deviation, or the mean of the distances, could be a measure of the variability in a data set. So we're going to take the average right here. We've got the sum, it's 44. Now we want to take the mean, or the average. Its value is the average distance of the data value from the mean of the monthly temperatures. It is called the mean absolute deviation. So here we have the sum of the absolute deviation. Now if we take the average of those, that will give us the MAD, or the mean. Now how do we do? We've already got the sum of something. How do we find the average or the mean? Well, we have to divide that by the total, right? The mean is sum divided by the total. So that's the same thing we're going to do for deviation. Okay. Same thing we're going to do for deviation here. So we've got the sum. Well, how many were they? There's 12, right? Because there's 12 months. So 44 divided by 12 gives us 3.7 as the mean absolute deviation. Okay. So what is that talking about? That's talking about each monthly temperature is going to vary. Notice we're talking about variability. So it's going to vary about 3.7 degrees away from the mean. Okay. Let's go to page 6. Look at dot plots for CDA. Okay. How much variability is there in CDA? Well, there's none, right? They're all the same. There's no variability. Well, if there's no variability, that means the absolute deviation is 0 because it doesn't vary. There's no variability. Therefore, does the MAD agree with your answer? Well, if we add all of those up, the sum is 0. If we divide by 12, that is equal to 0. So there is no variation. Yeah, the MAD does agree with my answer in part A because the value is 0. So if there's no variability, you're going to have 0 for the MAD because there's not an average distance away from the mean. It doesn't vary. Page 7 obviously is not there. That must be it for this lesson. Okay. So remember, MAD, mean absolute deviation. How do we find the mean? Let me just write it out. Mean is equal to the sum over the total. And here, since we're talking about deviation, we're going to find the absolute, how far away each one of them are. And so that's the reason why we're using the absolute, because if we were using those negatives, when we're talking about to the left and to the right, those should have been equal to 0. But we're taking the absolute deviation of negative 10. So that is 10 when we're adding up for our sum. That's the reason why I call it absolute deviation. But we're just going to add up all the absolute values, get the sum, and then divide by the total.